All right, moving on to section 5.2, parallel lines and transversals. Okay, we're going to skip the constructions and go down to the vocabulary. Parallel lines are coplanar lines that never intersect. So recall from the previous unit that coplanar means lie within the same plane. So parallel lines are lines that lie within the same plane that never intersect. The symbol for parallel are these two lines that are vertical. Kind of looks like the number 11. And this is the symbol that you would want to use when you want to write down that two lines are parallel. All right, so the markings on a diagram to show that two lines are parallel is that you'd use a combination of matching arrows. For example, if we are looking at these two lines, line AB and line CD, all right? Now, again, initially they may appear to be parallel, but as we've said before, you cannot assume from a diagram unless you're given information to state that they are parallel. Okay, so just because they look parallel, they are not necessarily parallel. However, if I use this combination of matching arrows, so if I put an arrow like in the middle of the line like this, all right, so again, remember, these are not tick marks, so we got to be careful that these are not tick marks. These are markings to indicate that these two lines are parallel. All right, so now we're going to go through an exercise of using those angle relationships from the previous lesson regarding transversals and lines, and specifically talk about what happens when you cut a transversal line through parallel lines. So here you see that the given is that line FG is parallel to line AB. Okay, so these two lines on the page are indeed parallel. We're given that statement. So then we have this transversal line cutting through those two lines. Now, all the responses to these following questions are if you have a transversal line that intersects parallel lines as a beginning conditional. Okay, so if a transversal intersects parallel lines, then we can conclude that corresponding angles, they are congruent. Okay, so if we have a transversal intersecting two parallel lines, then the corresponding angles are congruent. What about alternate interior angles? If you have a transversal line that intersects parallel lines, then the alternate interior angles, they are also congruent. Okay, so we have transversal line intersects parallel lines, then the alternate interior angles are congruent. What happens to the same side interior angles? If you have a transversal line that intersects parallel lines, the same side interior angles, they are supplementary. All right, so they're not congruent for this one. The same side interior angles are supplementary. If you have a transversal line intersecting parallel lines, the same side interior angles are supplementary. What about the alternate exterior angles? If you have a transversal that intersects parallel lines, the alternate exterior angles are congruent. And finally, the same side exterior angles. If you have a transversal that intersects parallel lines, the same side exterior angles are supplementary. All right, so let's take a look at the examples on the next page. says determine the angle relationships between the angles and find the measure of each numbered angle. All right, so we see a transversal cutting through two lines. But before we do anything specific with an angle relationship, we need to know more about those two lines. Now we see these strange markings not at the ends, but kind of on the line. So these markings are telling us that these two lines are indeed parallel. And that's important information to know, because from the previous page, we know that there are specific relationships regarding transversals cutting through parallel lines. All right, so now that we know that these two lines are parallel, now let's look at the relationship between angle 5 and that other angle that measures 65 degrees. Those two angles are alternate interior angles. And because they're alternate interior angles with respect to parallel lines and a transversal, we know that the measurement of angle 5 is exactly the same as that 65-degree angle. As we stated in the previous page, if a transversal line intersects parallel lines, the alternate interior angles are congruent. Look at example B. Again, we see the markings in the bottom of those two lines. Those two lines are parallel. With the transversal, we have specific relationships. Angle 8 and that 42-degree angle are alternate exterior angles. So if we have a transversal intersecting parallel lines, the alternate exterior angles are congruent. So angle 8 measures 42 degrees. Example C. Again, parallel lines cut by transversal. This time the two angles that are marked up are same side interior. What do we know about same side interior? Well, same side interior angles created by a transversal line intersecting parallel lines are supplementary. So therefore, angle 6 measures 50 degrees. Because when a transversal line intersects parallel lines, the same side interior angles are supplementary. Let's take a look at example 2a. We have parallel lines being intersected by a transversal. Angle 3, we're going to say, is equal to 50 degrees. But what is our justification? It's if a transversal intersects parallel lines, then the corresponding angles are congruent. Looking at the next picture, angle 1, how is it related to the angle that has a degree measurement? Well, those two angles are alternate interior angles. And because it's a parallel set of parallel lines cut by a transversal, that means that alternate interior angles are congruent. Now I'm going to allow these abbreviations, but you got to be careful that you're using the appropriate abbreviation. Okay, so AIA stands for alternate interior angles. So if we have parallel lines cut by a transversal, then alternate interior angles are congruent. That's our justification. Angle 2, that also measures 82 degrees. But we need to be careful of what our justification is. It's because vertical angles. And so if these are vertical angles, which they are, then they are congruent. Now let's see what you can do with part C. What is the measurement of angle 1? And what is your justification? Angle 1 measures 118 degrees. Our justification, because if parallel lines are cut by a transversal, then the alternate interior angles are congruent. What about angle 2? What is its measure, and what is your justification? Angle 2 measures 62 degrees. Why? Because if parallel lines are cut by transversal, then the same side interior angles, SSI, same side interior angles are supplementary. Okay, moving on to example number 3. We want to find the value of x. So set up your equation, but then you also need to justify why you set up the equation you did. All right, so hopefully you wrote the equation 13x minus 5 equals 86. But what is your justification? You need to make sure you know that I will be asking you this on the quiz and the test for this unit. So what caused us to make 13x minus 5 equal to 86? If lines are parallel and they're cut by a transversal, then the alternate interior angles are congruent. That's our justification. That's our reason for writing this equation. X equals 7. Okay, let's finish up with example number 4. Write an equation to help you solve for y, but also make sure you state your justification for that equation. So for this one, you should have written an equation 6y plus 120 equals 180. What is the reasoning? If we have a transversal cutting through parallel lines, then same side interior angles, SSI, same side interior angles are supplementary, which means can those two angles sum up to 180 degrees? That's the justification for our equation. That's what you need to be able to write on quizzes and tests for this unit. Okay, all right, so that's it for today. Move on to the 5-2 homework.